So welcome to the walkthrough for the so-called frequently made mistakes for assignment number 2. Not everything I'm going to go over here, of course, is a mistake, but some things are sort of style issues. Other things are suggestions on how you might improve the code in terms of its efficiency, in terms of its normalization of data structures and database tables and so on. First, please make sure you document your code. A lot of people are really skipping on that, so make sure you do that. There's many different ways to implement this assignment. People have come up with about 3 or 4 different ways that are sort of canonical. One approach involves using the one-to-many mapping annotation or some variant of that in the student and course classes. So and that works fine. You can get it to work that way. There's some downsides to it that we'll talk about when we look at the code in more detail. But one way you might improve performance and simplify your code by not having as much of the logic being done with the Java part, but instead done by the database, is to make some kind of course registration class and give that a pair of private fields, one of which would be course, one of which would be student, and then have those fields be defined to have many-to-one mappings, one for each field. So if you were to do that, and then you were to create a course registration repository that is going to basically implement the JPA repository, you could add various methods, things like find by course ID, which would return a collection of course registrations, or find by course ID and student last name, where you give it a course and a student last name, and it would give back a collection of course registrations that matched those particular parameters. Another helpful method that we'll take a look at in just a bit would be delete by course ID and student ID, where again, you could give it a course ID and a student ID and have it delete that. And then you could auto-wire this repository into your registration controller or into your registration service if you used the registration service instead of the controller as your implementation vehicle. And then you could use this repo either in the service or the controller to simplify and enhance various endpoint methods. Now, again, keep in mind, you may have named them something differently than I did, but you could call them, add student to course or remove student from course, get students in course, get students in course by last name. Those are various endpoint methods that could use some of these course registration repository methods that I just mentioned here. And as you'll see, that can clean your code up quite a bit. Okay, so let's talk about some other stuff. Let's start delving into this. If you're going to have a course registration class, you should probably use the many-to-one mapping for student ID and course ID. That'll help the JPA stuff work better and be more optimized, and you have to write less code. A number of people were putting response body annotations in front of the return type. You don't really need to do that. As far as I can tell, it works fine if you take them out, so no real need to do that. This particular code is unnecessarily complicated. There's no need to basically create a mapper and take in a HTTP servlet request as the parameter and then convert that into a course using a mapper. Just go ahead and just pass in request body course as the parameter instead of using HTTP servlet request. So that'll clean things up a bit, use the type system more effectively. There's a number of simple things. These, again, are not mistakes. They're just ways to improve your code, make it more concise. You don't really need to save the course and then return the course. You can just chain those things together, say return course service.save course. This is also not really a mistake, but you should think carefully about how you want to name your endpoint methods. This particular endpoint method is called getStudent, but it returns a collection, so it's probably better to call it getStudents. And then something else to remember here is you don't need to initialize this local variable here with as an array list, because the thing you're going to do here is go and grab the students from the student service. So you're just blowing away that memory immediately and not getting any benefit from doing the extra allocation. Again, keep in mind there's different ways to do this. Your approach, as long as it passes the tests, is fine, although you may find it more work. So a whole bunch of people did a many-to-many mapping for course, where you'd have a course that would have a collection of students, and then the student class would have a collection of courses. and there was a many-to-many mapping there. It's certainly possible to do that. I think it makes the code a little bit more cumbersome in a few places, but you might just think about factoring some of this stuff out, sort of normalizing it a bit better, and using course registration as a separate class with course and student as its fields with many-to-one mappings. Same thing down here, same issue. You could do the same thing with student. When you start using generic types, please get in the habit of using the proper syntax for this. Don't just say set, because that makes it a set of objects, but you want to make it a set of the appropriate stuff here. I think it's a set of courses. So make sure that you do that properly. Here again, you don't need to have a request body as the return type for this particular method. Also, rather than returning a collection, I recommend returning a list and then parameterizing the list properly. So again, make sure you put the right types here rather than just leaving it like this. That just inviting problems. Your compiler should probably warn you about that, and it's a good warning to heed. A bunch of people went to some fair amount of trouble to take the result that comes back from various operations on repositories, most notably find all, which returns a list. And then they would turn that into a stream and then convert it back into a list. You'll see a bunch of different variants of this as we look through the code, each of which has its own pros and cons, but all of which I believe are completely unnecessary. So you don't need to convert a list into a stream and turn it back into a list. That's belt and suspenders overkill. Here is another thing that's inefficient. So this example was making a new list of courses with array list and then using find all, which gives a list. Then we iterate over each element, which is a course, and we add that. It's just really complicated, very brittle, very error prone. It's all too easy to forget to initialize the local variable result with a new array list, for example. And all of that is just completely not needed to make this work properly. Here's another example. There's a helper method here called create course. And I don't really think there's a need to create a new course. I think you can just reuse the one that's passed as a parameter. You don't need to go ahead and go to all this trouble. So I didn't see a need to have that. So you should just be able to use the parameter that's passed in. That'll work just fine. Here's another example where if you had a course registration repository, then you could go ahead and simplify things quite a bit. And all you'd have to do here is sort of call find by course ID and student last name, and it would go ahead and do the bulk of the heavy lifting for you. So you don't really need to do all this extra work. As a general rule of thumb, if you find yourself writing a lot of code where you're doing a lot of work in the Java part, it's probably an indication that something has gone amiss. A little bit of Java code's okay, but writing a lot of Java code here probably means that your data structures haven't been organized properly. So it just makes it more complicated. Here's another example. Again, if we were to add a method to the course registration repository called delete by course ID and student ID, then we could simplify a lot of this stuff. We wouldn't have to do a delete with a find by student and course and so on and so forth. So just make things a little bit cleaner. There was one solution that had all these checks to see if the IDs were null. I wasn't quite sure why the IDs would be null, but that's probably an indication that something's gone awry. So maybe your initialization wasn't done correctly when you created the entity, and the ID was not done properly, but it should not be null. So take a careful look and see if you really need to have these methods. And of course, if you do need these methods, make sure you document why you need these methods. A lot of people, again, are just writing code that isn't documented. So it makes it very hard to figure out why it's done in a particular way. Let's take a look at some other issues. This is the get students in course. This is a get students in course method, endpoint method. And again, this can be simplified quite a bit by having this course registration class. This is the kind of code that you really don't want to be doing here. Most likely, you could probably clean a lot of this up. And if you do find yourself needing to do this kind of code, then it's probably a good idea to get in the habit of using the Java Streams model, because it's just so error prone to have to remember to create a new array list and so on. And you could probably do this much simpler with stream and map and collect to list and so on and so forth. So if you know Java streams, it's probably a good place to use it if you even need it at all, because you may be able to get rid of a lot of this code by refactoring the data tables and the database portions with JPA. Here's another example. There's no need to take something that comes back as a list and then wrap it up as an array list. That's just adding extra levels of indirection or just extra copying that isn't necessary. Speaking of not being necessary, you don't need response body here. And again, I think you could do this with a course registration class to kind of clean up some of this stuff a bit. There's no need to put HTTP servlet response parameters in each method if you're not going to use them. You can just leave them out. And in this particular case, there's a bunch of examples here that are sort of variations on the same problem. The person was taking course in as a parameter and then calling course.getStudents, but of course that doesn't make any sense because the parameter that's passed in is not what you want. You want to go look up in the course repository in order to find the students, not calling it on the parameter. That's again probably a good reason in many ways not to have these sets or collections or lists or whatnot in the course or in the student classes, but instead to have this more normalized approach with a course registration. This isn't really a mistake, it's just a simplification. Please get in the habit of using method references instead of lambda expressions. Your compiler should give you a little warning and basically offer to give you the change automatically if you push the right button. So that's a good habit to get into. Now here's some other things. I'm really not sure why there's so much complexity here. This code is taking a list, getting a splitterator to the list, making a stream out of the splitterator, then collecting it into a list, which is completely overkill. Just return course repository.findAll and you're done. And also it's a good idea to get in the habit of using
Professor
get course instead of get course.
On those, course repository.findAll returns an iterable. Does that not need to be a list return type?
I think it depends on how you define it, but my implementation of course repository returns a list or returns something I didn't have to do anything with it. I just was able to say return find all. So it worked fine.
You can also change the return type of that get courses method to be the iterable, and Spring seems to take care of that too.
I think collection is an iterable.
Collection should be an iterable, yes. So the bottom line is you do not need to write this kind of complicated code. So I think we talked about this in the last frequently made mistakes video as well. So please get in the habit of trying to make it much more simple. There's no need to do all this stuff. That would be very ugly and un-Java-like in some ways. Okay, another thing to do is get in the habit of using the right capitalization scheme, lowercase letter first instead of uppercase letter. That's just inconsistent. Same thing down here. And again, there's a bunch of examples of code somewhat along these lines where the person kind of goes through and deletes each of the course registrations manually. If you use the appropriate mappings, the many-to-one mapping in the course registration fields for student and course, then it should be the case that you can just delete all this stuff in one fell swoop without having to do iterations and so on for that. So that'll clean it up quite a bit. Here's yet again another place where it really helps to kind of clean things up. This code is very long and complicated, unnecessarily complicated. So if you refactor your code, as we had just talked about, to have a course registration class, which sort of normalizes the association between a student and a given course, then that will, I think, greatly improve a lot of the code. And you won't have to do almost any of this stuff. It all just gets subsumed up into the course registration repository where you can define the various methods you need in order to get access and do the operations that manipulate those tables. So those were some of the frequently made mistakes that I saw, or things that could be improved. Not everything is a mistake, of course. The gold standard here really is making sure that you pass the tests. But obviously, if you have any questions, I'm happy to talk about them.
So whenever you're using find student or find course, and when I'm using them as an optional, and then when I'm trying to use them into the method, it says you expect course, but you're passing optional. How do you handle that?
Are you talking about the fact that a lot of these calls return optionals instead of the actual values?
Right.
There's a whole bunch of different ways you can do it. One way is, and this is not the best way, by the way, but it's one way to do it, is just whenever you have a method that returns an optional, just put a .get after it, which will have it not return, it'll have it return the actual value, not the optional. That's one way to do it. Another way to do it, as you can see here, is to check for is present, like this. So you get back an optional and you check to see if it's present. And if it is, you do something. Otherwise, you set an exception code or an error code or throw an exception or whatnot. Yet another way to do it is to use the map call on optional, which will only run the code that you put in the Lambda expression if, in fact, there is a value present. That's probably the cleanest way to do things. And then there's all kinds of other variants of that where you can, chain on to that or else throw or other things in order to be able to get the proper exceptions if things go wrong.
Okay, thank you.
Doug, I have a question.
Yeah.
So if we use many-to-many relationships, isn't like Spring automatically creating this course registration on its own? It's kind of transparent to us, but it's still creating it because the join table annotation, we do have to specify the name of the table, and and it does specify two columns, student ID and course ID. So it looks like Spring is automatically doing it for us. So is it kind of recommended to still kind of use one-to-many? Is it like the preferred way to do this?
You're welcome to use whatever you want to make it work. But for the people who did the one-to-many in particular, I saw that there was a lot of extra code that was generated, not generated. There was a lot of extra code they had to write in order to do things like we see here, go through and delete each element individually. So whatever you'd like to do, but strive to make it the database's responsibility to do the bulk of the heavy lifting rather than kind of foisting that into the code that you write in Java. Just because it's, especially things where you have to go like linear search. There was a couple of cases where, let's see, trying to think. This, I may not have it here, but there were situations like this where the person was using the remove method in order to go and remove something from a list. Well, that's obviously doing a linear search. So I would hope that a good database implementation would do something more efficient than a linear search to remove something in a table. It would probably use a binary search or a hash lookup or something like that. So if you find yourself writing a lot of extra code to do the operations, it may mean that you haven't quite factored out the tables properly and the annotations. And so that's what you want to rethink at that point. And I think the most streamlined, normalized way that I've seen so far, and several people did this, and their code is just absolutely gorgeous. It's just a bunch of almost like one-liners almost everywhere in their implementations of the endpoint methods. The typical approach there was to have basically a course class that was an entity with a course repository, a student class that was an entity with a student repository, and then a course registration class that had the many-to-one mappings for course and student, and then have those also have its own repository with those methods I showed you up here. And then you can look things up in ways that simplify lots of the other code. Again, you don't have to do it that way, but
if you create one-to-many on course to the student, it automatically creates that course student class as a shadow class, right? So would it not achieve the same result?
Again, look at your implementation and see if I had comments. I mean, a lot of people did it with subtle variations. Some people did many-to-many mappings on course and then didn't do it with students. Some people had one-to-many mappings on student, one-to-many mappings on course. But if you look at the code, oftentimes they would have extra code that was not necessary if you did it the other way. So if you're able to do it with that implementation and you have no extra code, then that's great. But a lot of people didn't do that.
Yeah, and I'm still struggling, but I just wanted to ask. Yeah. We'll check. Thanks.